Hello everyone and welcome to our next chapter of the webinar series FM Unlocked. I'm Riccardo Cerati from VID Farkil, and here it's an honor for me to be together with my colleague Olivier Albert, which is a wide experienced expert in the fire protection industry within buildings and healthcare applications.
Hello everyone.
And also today I'm really pleased to have together with us two big industry experts coming from India, from France, Vinod Kapse and Mr. Saburdi. Hello and welcome, Vinod. Can you please just quickly introduce yourself for the audience?
Thank you, Ricardo, and it's my pleasure to be here on this session. I'm Vinod Kapse, a consulting engineer based out of Mumbai, India, and I'm engaged in design of fire protection and life safety systems for buildings, for commercial buildings, for industries, as well as data centers. So we are based out of Mumbai, and we offer these services in India and in neighboring countries. Thank you.
Thanks a lot, Vinod. Looking forward to the Q&A sessions together. Hello, also Mr. Saburdi. Can you please introduce yourself for the audience?
Hello, everybody. I'm Aurélien Saburdi, major on firefighter in fire department in France, which is a small fire with smaller fire department in the middle of France. I am in charge of prevention risk, prevention fire, and follow of construction in a residential building and public building in my fire department.
Yes, great. Thank you so much. Also really looking forward to have the Q&A session together with you to understand much more insights coming from France that can be applied in different countries around the world. But now going a bit deeper into the topic of this webinar, I will start introducing quickly and briefly what VID does globally, and then we go much more in details, talking about the different applications, the challenges that we have, and how also FM can really change the face of the world in terms of fire protection. So as I said, we are VID Farkil. It's a global leader in the water mist industry, working since more than 20 years, only focused purely on low pressure water mist developments. Companies, of course, wide and full of all the ISO approval needed as a global manufacturer. And just to give some numbers, producing almost 650,000 components, selling and installed every year globally. The company is purely focused on a strong quality and approval policy. Apart from ISO, there is strong relation with FM approvals in terms of quality, in terms of testing, in terms of research and development, but also inside of the same specific product, because all the products are made in traceable batch and they are all 100% tested before shipment. That means that for a customer, it's a wide and extended reliable technology in terms also of quality and performance in general. Just to give some numbers, it's audited around 13 times per year by different auditors to ensure the best performance in terms of quality and performances. Giving some numbers, it's approximately 13 FM approvals, different DNV approvals, mainly for the marine application, but also IBS approvals, mainly covering the N4097-2 in Europe, but also civil defense approval covering the Middle East. Apart from what is the approval and what is the product, the company has a strong commitment to the industry in terms of participating to standardization, being an active part of CEN, being an active part of NFPA, of IMO Solans. So as a company, as a manufacturer, we are a truly believer that being part of the industry means also being part of standardization process, but as well also being part of committees and associations, like being part of the FM Approval Manufacturer Board Council, being part of IWMA, representing, of course, water mist globally, being part of the European Fire Sprinkler Network, but also FSSA in the United States. And this helps the company, of course, to being an active part of the industry, but also being able to be part of different markets worldwide, like buildings, like offices, hospitals, wooden buildings, historical buildings, heritage, data centers, industry in terms of power generation, power distribution, manufacturing, road and railway tunnels, aircraft hangars, but also don't forget about marine and offshore. So it's a wide, extensive range of product present worldwide, working in different kind of markets and application. But now I think it's time to go much more in the topic, and I want to leave the stage to my colleague Olivier, especially If we look at FM, Olivier, why FM is really a key and why FM is really important in terms of standards?
Yes. FM is the main company to test water mist. So because it's the first one to create the test, the protocol test is the FM 5560. It's the protocol where you can find a full case test for a lot of things. I will introduce this after. And you have also in FM lot of data sheet, and the data sheet 4.2 it's mainly for water mist for the product, but also for the design and installation and after sales activity. For sure, there are also the datasheet for the application. Yes, so this datasheet is the 326. It's really important because you have the classification of all the risk for the building. So the FM have also all the promises to do the test. You can do the test for fire test for the composant, and it's also an auditor company because she go to the factory to control if all the process for made nozzles, made pump unit, it's in accordance with FM. And FM is the main assurer over the world. It's totally recognizing and benchmark for all the other assurer on the building. So now more in the deep for hospital. The benefit to use water mist for hospital is there are really a lot of. So because you have the benefit to save for sure the people, the patient and the person on the building. It's really important, and it reduces the smoke emission because the water mist starts at the beginning of the fire. And as it starts at the beginning, the fire is too small. There is less smoke, and the smoke is the main thing that die the people. So if you reduce the smoke, the people and the patient is more safe. It's good also for the owner because the owner have more confident with the building when there are water mist on the building. It's also good for reduce the damage for the water. When you have protection on the building with the water system, the water mist is the best because there are less water. Also for the assurance, it reduces the cost of the assurance. So, and you can use also, depending of the country, of the rule of the country, you can reduce the smoke extractor, or you can use the water mist to replace smoke extractor. And it's the same for the structure, for the fire resistance of the structure. If you know, the hospital sometimes is very old building, so you can use water mist to compensate the fire resistance of the building. Maybe I have lost some benefits, Ricardo.
Yeah, but this is great at the end, and you see the benefits are really amazing on that side. It's not just being, of course, unlocking different benefits of in terms of fire protection, in terms of water saving, of course. But I think the main topic you touch is the most interesting one: the management of smoke, the activation when the fire is not that big, the faster reaction against fire. And at the end of the day, all these application means faster evacuations, means less collateral damages. And we think about an healthcare application, evacuation is one of the most difficult part because not all patients are able to leave a room faster. So being able to contain the fire, to manage smoke, it's also guarantee a safer evacuation in general. And that's because the effect on the fire triangle, it's different. Now in the screen back to me, you will see a video from a fire test that really shows how the effect of water mist is different compared to the other fire protection system. Because if we think about sprinklers, we think about just absorbing heat energy from the fire. So using water, which is the most known element in nature in absorbing thermal energy, to absorb heat, and that's to control, of course. And when we use gas suppression, we mainly reduce the oxygen. But when we use water mist, we work on both sides of the fire triangle. So we absorb heat from one side, but we also stop the oxidation. That means being able to be much reliable, being able to be much faster in control and suppression, but also at the end of the day, it means evacuating. It means controlling smoke, it means controlling fire, it means preventing collateral and structural damages. So it's a wide, extensive range of benefits, of course. And now, thanks with FM, that's where the new approvals released by FM in the Appendix P, so the HE2 and HE3 are unlocking, is the chance to really swap and from a traditional application-based use of water mist to an occupancy-based use of water mist. If we look at the old protocols released on water mist and we think about OH2, there is an OH2 risk for sprinkler, which is covering a wide range of application. But if you look at OH2 for water mist, it's just OH2 car park. It's not OH2 or anything else. So it's purely focused on the application, and you have to apply that test specifically for that specific scenario. When it comes to occupancy base, then it's a wider, extensive coverage. And if you think about HE1, HE2, and HE3 areas, we can really look into a full building protection, which is much easier to be applied, much easier to get a local compliance because it's covering a wider range of hazards. Of course, there are limitations done by the testing, but the application is much wider and can be, of course, like reception areas, retail spaces, if any, shopping centers also, offices, meeting rooms. When it comes to hospitals, can also be generator rooms, can also be, of course, laboratory, any kind of room that is used for surgery or for the rooms, simply the rooms for the patients. So it's wide and easy in terms of compliance because of that. And just an example, when it comes to application base, and I think this is where we gain the benefit working occupancy base. If we think about the cars, how the fire load and how the composition of the cars change around the world. And if we think about on OH2 car park fire test, which was limited to an old generation of cars, what's happened with the new ones? If you look at what's happening with the car development and the type of the fire load and how the fire load was spread across the cars, we started in the early 80s or 60s years in which the metal was the main component inside cars. And then, of course, fuel was a component increasing that fire load. But we jumped into a new generation of cars in which plastic is taking the lead. There is much more plastic instead of the past. And if you look at what's happening now and what will happen now on, even in the future, there will be an extended use of electrical equipments, of course, but also of lithium-ion batteries for the EV cars, in which the fire load is increasing and increasing. So how we can stay stuck on a simple application-based test when we have a full occupancy classification? And that's what happened, for example, within the FM approvals. Being occupancy-based means that if we increase the fire hazard, if we increase the fire load, we can swap to a greater fire design, like from HE2 to HE3 for the cars and the parking garages. And if we have a test for OH2, which is simply done for application, then we have no room to go OH3, because OH3 in Europe cannot be used for the cars because it's a test done for shopping, sales, and storage areas, which is completely different in terms of application. And I believe that's one of the biggest benefits. And I think it's good also to run through what it means HE1, what it means HE2, what it means HE3, how can be applied, how FM is seeing them, and what do you think? I think it's a good time just to run through a bit the HE2, HE3 application, because classifying occupancies.
Yes. So
important.
go a little bit more on the on the deep, I would like to say. For the room, we have the classification HE1. For the commit area is HE1. For the technical room, you have HE2, sometimes HE3 as well, depending of the technical room. Storage room, for example, for the pillar in the hospital, you have a storage a lot of time, and it's HE3. So as you can see, all the room have the classification. So if we go to emergency generators, is machinery space or local application, depending of the size of the room, how many generators. We will see more after. For car park is HC3. For computer room, we have data centers, processing test, and for cable on the corridor as well, you use HC2. So in the laboratory is HC1, depending. Sometimes we can go to HC2, as you have explained. We have classification with FM, and we can move on one classification to another classification if the risk is more big. So with FM, we have also the good thing is because when you use sprinklers, you use square meter to define the size of the pump. Easily explanation. So, but FM it's the first to introduce the test. When the test and the number of nozzles. So for water mist, when you have on the test activate a number of nozzles, you multiply by 1.5, and you have the nozzles for the pump unit to define the pump unit. This is it's very good for water mist because like this we have less and less water. Why FM use this is because the heat radiation is totally blocked by the water mist. So we activate less nozzles and sprinkler. And like this, we have totally the benefit of water mist. So I explain now in details. So for the rooms, standard rooms is we have for the pump unit only 9 nozzles or 150 square meters, 40, excuse me. But for HC2, we have only 9 nozzles because when we have done the test, we have activated on only 6 nozzles. And if I continue on storage, is the same. 9 nozzles on the machinery space. It's the space of the room or the size of the generators. Parking garage is same 9 nozzles, and laboratory it's only 9 nozzles or 140 square meters. And if you go on data centers, room is only 6 nozzles because when we have done the test, we activate only 2 nozzles, and the minimum is 6. So
I think one of the interesting part, Olivier, is that when we move to a nozzle-based design, we also change the design criteria in a way that water mist is much flexible. I would say when you design for OH1, OH2, OH3, and you are related to a surface, you actually need to count how many nozzles you have in that surface. And if you have like obstruction that are leading you to have a wider amount of nozzle, you may end up with a water storage or flow rate, which is too much perhaps for that hazard. And I'm not saying that it's not performing, but perhaps we are too much over designing the system.
Yeah. So HC1, excuse me, it's 9 nozzles is the minimums on the designs. And or 140 square meters is the first design in FM. And at these times, we stay with square meters. But after that, HC2, HC3, is one of the tests when the activation of the nozzles in the test is really important. So when we do the test at 7.6 meters height, and we activate only 6 nozzles during the test and during all the tests, because when we spoke about test is test schedule 1, but at the same time we have not only one test, we have full of tests, because one test is like this and like this and like this. I'm not here to explain what is a test, but I explained that is not one time you arrive to extinguish the fire. It's few tests. So around all of the tests, we activate only 6 nozzles, and for that we have only 9 nozzles on design for the pump unit. Machinery space is another case. So in machinery space, we have two cases. The first one is total flooding. It's one of the first tests for water mist. If we go on the knowledge, on the history, it's the one of the first. I think it's before 2000, this test.
The marine application started when they used to protect those engine rooms inside the ships.
So this test is total flooding. We use for this test in same times the cooling and the oxygen, reduce the oxygen. So one of the things is too important, it's the opening part. So it's in the case of the volume is under 260 cubic meters, the opening is less than 2 meters, 2 square meters. And if it's over, the opening will be less than 4 square meters. If it's not the case, we have to move to a local application. So another thing, it's good to use total flooding when there are only one NG on the room, from my point of view.
Yes, totally agree, because at the end you have to discharge and fulfill the complete room of water mist.
Yes.
And if you have two gensets that you may discharge to a genset that doesn't need to be discharged over.
Yes. So when you have two, 3, or more than 3 NG, the best solution is to use local application. Like this, you activate only on the generators, and you can activate on the generators without stop the generators. It's possible as well. So when you are in the hospital and the NG is work or die, you activate on the generators until the interruption. Yes. So local application is also a part of approval by FM.
Yeah, and I think when it comes to the local application, and we have Vinod here, which is the experts in India, and many data center and hospitals needs local application, especially sometimes when we look at the data center in Europe, it's containerized. And when we look at India, for example, and Vinod knows much better than me, they have complete DG building sets. That means having a lot of generators in that building. So being able to localize the discharge, it's a benefit for the operation. But of course, when we look at FM in general, there are challenges, of course. Classifying areas HE1, HE2, and HE3, yes, but there are some applications that are not covered by any standard, also not for sprinkler, and also not for gas suppression or for other kind of technologies. And I believe, and I truly believe, that when it comes to water mist is that technology that can solve different challenges. But before jumping into that, like challenges like atriums or facade protection, one slides I think it's good to discuss, because we got also many questions on the previous webinars from our colleagues regarding the storages and regarding FM datasheet 326. When you look at 326, the datasheet is called for non-storage occupancies. So is that really that datasheet covering storages? Is not covering storages? So the question is, yes, that datasheet covers storage, of course. Not really big warehouses, of course, but some kind of storage that can be classified as incidental. And this classification is linked with some limitations, of course. The first kind of limitation is the type of goods that we are storing. Are they commodity class 1, 2, 3? Basically, all those commodity classes that are not including a heavy percentage of plastic. Are those classified as commodity 4, so including a wider range of commodity of plastics? Of course, we are not talking about expanded plastic, but we just talk about unexpanded plastic. But those 4 categories are covered within that, and there are limitations, but the limitations are mainly on height. For example, for commodity class from 1 to 3, the limitation is up to 3 meters and no more than 20 square meter of rack aisle, which is quite a lot if we look at 20 square meter of rack compartment. And And the same is also for commodity class 4, for example. Of course, we need to go a bit lower in terms of storage height because it's a different fire load, but there is also 6 square meter of rack compartment. And when we talk about hospitals, when we talk about buildings, those limitations are easy to be matched. The same is for data centers, for example, is for many applications. Of course, when we talk about large warehouses, then it's different, but for buildings, it's quite easy to manage. And it's important for the customer to understand which are the limitations to stay with, to be fully able to deploy and to be fully able to be compliant without any issues from the fire brigade side or on the authority having the jurisdiction. The same is for the high movable shelving units. Hospitals, especially the old hospitals, have a lot of clinic folders, and those clinic folders have to be stored somewhere and have to be kept in the hospital for a certain amount of years. In some countries is even 10 years, for some countries is even going up to 20 years. So some of them are digitalized and there are several rooms inside, but some of them are not digitalized, especially the old ones. So that means that storing them means creating archives, and to create archives, the best way to create archives is to use the high movable shelving units because they are quite compact, they are quite able to contain a lot of files, a lot of folders, and this is something in which FM also looked into. When we look at OH1, EN 14972, when we look at NFPA, there are some limitations, some declassification, but it's not every time that clear. When we look at FM, that thing is having a specific chapter inside 326 and is expressively explaining how to do it, how to protect them, also giving limitations. And the usual limitation is 2.4 meter ceiling height. That means being quite flexible because normally those shelves have to be easy accessible for people, no need any kind of stairs to jump on that. So 2.5 meter is quite easy to do it, and there is no limitation in surface on deploying them. So it's quite flexible also on the storage side, I would say. But then there are special areas also, facades, for example, atrium, large atriums, some kind of attics, some kind of wood part, and Olivier will tell us much more about the wooden structure protection, which it's a kind of special application that is growing and growing much more, specifically in Central and North Europe, but we can expect that it's growing also worldwide because of the much more sustainable structure technology. This is a pure example of why WaterMist can go beyond everything that the standard was planning in the past. Let's suppose that we are entering into an hospital. We have a large lobby areas, which is a large atrium, perhaps even 15 or 16 meter ceiling height or more than 12. And we know that when we are more than 12 meter ceiling height, it's just impossible to detect the fire because to trigger that nozzle, we need a really huge fire. And if we have that huge fire, then it means that we have bigger problem than the fire protection system. So going into an atrium approach, and that's the specific test protocol that is not developed by FM, but is developed by EN 14972. It means also having something that can support the authority to be much more compliant also on atrium protection. And it's a deluge solution with nozzles placed alongside the atrium, spraying as you see in the slide, and it's triggered by a fire detection system. And then the nozzle are placed at the lower ceiling height, ensuring a proper spray. And we know many customers ask, well, what about the ceiling? Yes, we can, of course, install ceiling nozzles to protect just the ceiling, but to have a solution specifically for atrium is definitely the best practice. Can be done both in combination if a customer wants, but this is the best to do, of course. And the same is for facades, for example, I would say.
Just for some numbers, just in the atrium, we have the spacing in two walls is 26 meters. So it's one of the biggest solution you can have, and in same times we have less water on the square meters. Is around 2 liters per square meter. So it's really less. And as the WaterMist is a good solution because it's in stainless steel. So the waters when it's come is clear. Totally clear. So for the atrium solution, you have a spray, you reduce really quickly the fires and the smoke as well. So for the hospital is a lot of time use this part because a lot of time you have on the hospital and there you have the big entrance or the hall for that, and or it's like art of the hospital, this part. And if it's you have fire here, all is stopped. So you have a lot of time to protect the atrium.
Yes, Imagine also discharging dirty water on critical items like
Yeah.
the surgery rooms,
Yeah.
the rooms to make all the radiography items. So
Yeah.
it's also heavy and wide, expensive items that a forced discharge can really damage, and this can cause a lot of cost for the client. So the client maybe even reduces insurance cost. We don't know, but it's a question and discussion of being, of course, much safer also in case of any potential forced discharge in general. And I believe the food building is also quite interesting topic.
Yes,
Olivier.
it's an interesting topic today. In Europe, we try to have less CO2 emissions. So a lot of building arrive now with in wood. So, but it creates a new risk because it's not only the desk, only the all they are in the room. Because before the building is in concrete, so there is no fire on the concrete. So now you can burn also the building. So it's one of the problem. But water mist is good solution because there are less water. On the wood building, if you put lot of waters, you have problem also with the wood.
Yes.
It don't like the water. Yeah. So today we have this, we have the sales case and the opportunity with office, hotel, university, healthcare, retirement home. Sometimes is an extension of the building. You can put 2 new level in the wood on the building because it's not heavy. So we have done some tests. The first test we have done is with the CERIB. It's to see what happened on the ceiling when you have a big fire and you protect with water mist. If you see on the picture, there is no lot of damage, just the color and few millimeters. I think it's less than 1 millimeters damage.
I don't believe that the damage was done before the discharge. It was perhaps coming from the fire. No?
Yes. So it's a really good solution. As it's a good solution for the room. In concrete, we control the temperature of the fire. We control the damage due to the fire. We control the smoke emission. So, and we have done another test in Effectis. It's for open space. Open space with sidewall nozzles. It's a big challenge because when the fire starts, you have a sidewall nozzles, so the nozzles on the wall, and you don't know which nozzles will be activated on the first time. But if you see the picture, you can see that the damage is really less with water mist, low pressure water mist VID. So, and we control the fire for sure. This is not only a ceiling, is a wood structure building. So there are pillar, beam, always in wood. So like this, the challenge is that there is no damage on the structure, because when you have the fire on the building, the fire brigade have to go on the building and to stay safe,
Yes,
to save the people. So that's the case.
Yeah, and I think also if you look at those kind of buildings and the type of nozzle used and the sidewall, for example, of course, we have to say the architects are always trying to optimize the aesthetic point of view, and that's sometimes the case. So we as engineers, I'm not saying we don't like the architects, but we have to deal with them sometimes. And if you look at this kind of scenario, as you said, the fire is growing far from the nozzle. And if we think about the sprinkler system, for example, the activation time will be much longer.
Yeah.
For example, so, and this will help me to guide you into a quick sum up of the benefit of water mist. So if we think about water mist in general, it's not just activating faster, but of course it's saving space in general. At the end, as we saw, regarding specifically for the hospital, it's a heavy property loss saving, because if you think about sprinkler discharge, dirty water plus smoke, the more smoke with sprinkler, so there is much more property loss with traditional system, and water mist can really trigger those benefits for the customer. Of course, if we compare also about high pressure water mist, is much less power working in lower pressure because we are much closer to the sprinkler pressure. So that means for buildings, such hospitals in which there is needed for power for emergency, we are not really taking too much of that power, and we leave the power for the emergency or for the operation in case of a lack of current, for example. This is quite important. And of course, the management of obstructions is different compared to sprinkler. And if you look at the design itself, it's much more flexible and also easy. And we know that for hospitals, the construction times is also important, because the more we can build faster, the more we can host patients faster, of course.
Yes, and the hospital is new building for sure, but the main park of building today is old. So, and all is not protected. So water mist is the good solution to integrate on the building already existing. It's not existing, and the fasal ceiling have no enough place for a big pipe,
Yeah, right.
and so on.
That's
So
right.
so water mist is a really good solution to protect the building existing.
Yeah, and of course, in a world in which everyone is looking into much more sustainability, much more sustainable construction material, water mist is of course a greener solution if we compare to traditional system, which are used a different type of pipes in terms of diameter, but also in terms of wall thickness. Because if we go with a black steel or a galvanized steel, the wall thickness is much different compared to stainless steel. But apart from that, and there is also a lifetime, of course, because stainless steel is much pure and the lifetime is much longer, of course. And all those combination together with less power, together with less water, together also with a stronger compliance and a stronger action against fire will lead water mist to be really a game-changing technology for the future. I see that we are running really close and out of time, so it's now the moment to have our guests on stage and to enroll some Q&A sessions looking from the audience. I see many questions coming in, and I would like to start with Vinod. Vinod, looking at the questions, I think I see a couple of questions that are really interesting. One is more purely focused on India as a local country, but one, yes, is touching India, but I believe it's really good for a global perspective. So perhaps we can start global and then we go local, Vinod, if it's fine for you. So as India continues to grow and urbanize, and we know that population of India is large and increasing rapidly, so increasing complex and high density buildings. How do you, what is your vision on the future of life safety strategy specifically for this context? And what way do you think that water mist can contribute for these advantages, or these advancements? Sorry.
Thank you, Ricardo, for that question. And you, as rightly said, India is on a growth path. Economy is booming. Government is stable. Okay. There are places like Mumbai where I work, where there is no horizontal space available now. The scarcity of land, as it's an island city. Hence, we have to go vertical, right? Hence, most of the buildings, most of the development that's happening lately is on high-rise buildings, super high-rise buildings. So we are going as up as 300 meters, 400 meters, right? All residential buildings, hospitals, as well as commercial complexes, corporate business buildings are growing larger in terms of floor plate and going high in terms of height. Even you look at other infrastructure, government infrastructure development in terms of government buildings, tunnels, if you talk specifically of tunnels, there are close to about 150 tunnel development in India. Okay, and these tunnels, I believe, water mist would be the most ideal solution. The length of tunnels. So we have a tunnel which is about anywhere between 1 kilometer to 5 kilometers. Okay, having ventilation systems, high ventilation systems, and water mist proves to be very flexible in terms of design, in terms of, by virtue of its pressure, it becomes the most suitable option for water mist in terms of tunnels. If you look at India in terms of codes and standards, there are no prescriptive standards for such new growing market in terms of tunnels, in terms of data centers. You know, India is booming in terms of data centers, all hyperscalers. The core in India has changed that any data it should remain in the country. Hence, a lot of data centers that are coming in. You're aware of data centers coming in India, and they are all hyperscalers, high-rise data centers as well as high-density data centers where gaseous separations are almost out due to reasons well known to everybody, and people are trying to go away from conventional sprinklers and looking at water mist as a solution due to less damage, less water, cleaner water coming out, ease for evacuation, firefighters' visibility for first responders. So if you look at the overall aspect, we are looking, and the government is more progressive and adaptive for new technologies, global approvals. If you have a product that is FM approved, we are more open to accept it. We are not saying that we want something that is ISI approved only. So in that way, we are very open and acceptable to the products which are tested based on performance rather than prescription, and open to adapt for these technologies to be accepted. And I think India is the right time now for global manufacturers to come into India, not only in terms of supply, even in terms of manufacturing. India is giving a lot of exemptions in terms of manufacturing and acceptability to internationally certified products to use in all varied applications that we are trying to drive this.
Thanks, Vinod. And I think you touch many interesting topics. And if you look at India as a country, and it's like really all the other than application that we see around the world, and maybe we have a country that is only having mainly tunnels, and we have countries that is mainly office buildings, or countries that is mainly high-rise. I believe India has all of them in one country. It's like a continent on this specific case. And I think what you said also about Mumbai and being there many times also together, you know, you said right. So Mumbai, it's an island. It's a big city over an island, and everything needs to be compact on that specific case. So yes, water mist is definitely giving a lot of benefits, and I think one is the most important one. And if I think about large hospital complex or large high-rise building, can be office, can be residential, can be every kind of application, I think evacuation is the most important benefit. I remember I attended on a seminar together with you, with the fire officers in Maharashtra, and you talked a lot about the smoke extraction, the ventilation, the evacuation. So how do you see water mist giving advantage on evacuation, Vinod?
Water mist will definitely add value in terms of evacuation. Yeah, that's simply because it extracts the entire heat. It controls radiation to a large extent. It uses very less water, so that you don't have wet floors, corridors for the people to evacuate, especially in hospitals. You have a lot of electrical stuff. If you look at hospitals in India, even in patients' room, behind the bed head, there are a lot of electrical measuring, metering devices connected.
Yes.
Okay. There is an oxygen inlet. There are hospital gases inlets, and then it's too chaotic in terms of wiring, in terms of systems that are connected to a patient in a hospital. Water mist, with its virtue of using very less water, it seriously helps in hospital application, and it aids evacuation. It seriously aids evacuation based on the fundamental concept of reducing the smoke particles, giving more visibility, reducing the toxic gases, maintaining the air much clearer, and minimum water so that the non-ambulatory patients can clear very fast.
Yeah, and And I would say, if you think again about Mumbai, being able to have a small tank in a compact city, it's quite a big advantage, of course. I will just ask you quickly a short one that you partially already replied, but I think it's good for the audience. So India has a national building code and a standard, which is IS 15519. If you can reply quickly on this one, how is India accepting water mist within these standards?
Yeah, Ricardo. See, India already has a code, as you rightly said. It's 15519 2020 edition, which is specifically on water mist. It accepts use of water mist for Class A, Class B fires, and it accepts droplet sizes from 0 to 99, low pressure systems below 12 bar, intermediate pressure between 12 to 34, and high pressure, of course, 34 and more. It's all the codes that accept wares as an alternate to sprinklers. It accepts for all type of systems, in the sense it accepts for deluge, engineered, pre-engineered, local application, zonal application, and pre-action as well.
Yeah, and I think that once the system is also in process of the right listing, specifically when it comes to India, but also worldwide, when we talk about global customers, it's a quality insurance for the product.
Absolutely. And if you look at the code, Ricardo, they've clearly mentioned that these systems can be used as an alternate for traditional sprinklers and deluge system, provided it has been cleared by the fire test by recognized laboratories.
Yes.
Okay, it gives a clear acceptance for national or internationally tested laboratories suited for an occupancy or an application, and you are free to use it.
Yeah, and I think then comes also to the importance of knowledge in terms of engineering companies and fire brigade communicating each other to select the proper hazard and then to take the right chance on it. And I think talking about connection between engineers and fire brigade, it's the good connection to connect now Vinod with Mr. Sabourdi in the Q&A session. So thanks Vinod. I know that there are also other questions for you, so we will share with you the questions and then you can reply even by video or even by email to the other questions. So thanks again for joining us.
Thanks.
Thank you so much.
Also now I want to welcome Mr. Sabourdi on stage.
Yes. Mr. Sabourdi, you are a fire brigade man in France, and it's good to have your knowledge and your experience about the intervention. So my first question is, and the first questions we have is, what is your view on emergency response operation in environment where the water mist system are deployed?
And intervention by emergency service in the presence of a water mist extinguish system is not an obstacle for us. This type of system is absolutely complete the resource on the first responders and on no firefighter operation to begin the spring in area that are difficult to access and the area with hazardous for emergency team. So it's a very, very good system for us. But if I can give you some advices for mist implementation of extinguishment water mist system, it's important to plan certain provision for emergency service during the construction phase. As the first, it's good to have an inlet connection to supply the system in the event of pump failure and viability of the water tank. This system allows fire engine and firefighter to feed the system and increase operational autonomy. And the second thing is to have a valve to isolate the specific zone and temporarily shut off the water discharge. This action prevents excessive water application and limits potential damage due to water. It's necessary to firefighter to control the system. So this water mist system is very good system for us, and it's important when you implement this system in a public building or hospital to share the system with a firefighter and prevention management system.
Thanks for your answer, Mr. Sabourdi. You have a lot of experience on that, and now as in India, I would like go more on the deep for French rules. Today, we use the water mist to compensate smoke extractor and sometimes fire resistance. But the question is, what is your perspective on implementing a water mist system as a substitute when the smoke extractor is absent or non-functional?
I think the implementation of the water mist system is a good substitute for a non-functional or missing small extraction system for many things. First, the installation of a water mist system is always paired in France with automatic door close device in sensitive area, such as sleeping quarter or hospital. And with the fire detection, we can close rapidly all the doors. And the fire detection system enables to compartment quickly in the case of fire, while the water mist system limits the spread and extinguish it. So the combination of the two systems, fire detection with closed device system and water mist system, is very performant. Secondly, emergency response time for firefighter in France are typically around 20 minutes for professional and even significantly longer for volunteer. During this period, the smoke extraction system removes the smoke, but do not actively reduce or control the development and fire. And with a water mist system or the end, we can actively fight the fire before emergency or fire brigade arrive on the location. This is a major advantage for us in the limited of the spread of the incident and its consequences. Furthermore, with the increasing use of bio-based construction material, not only in France, we have a lot of wood in residential building, on public building now for decrease the CO2 and for climate. The installation of fixed automatic extinguishing system has become a key asset for us and for the safety of the public.
Thank you, Mr. Sabourdi. Thank you for your comment, also for the wood building and wood structure. Maybe you have more comments?
No, I would say thanks for both of the guests. You really provided interesting insights that, of course, on Vinod's side is more on India and Mr. Sabourdi is more on France, but both insights can be really definitely used on global scale and can support every countries, and the smoke extraction is definitely an important topic, and the compensation is giving a lot of benefits to every customer. And if I think about Vinod and India, the smoke extraction, reducing the smoke extraction using water mist in a complex situation like large buildings will definitely help every country in this specific approach. So thanks again both, but also want to leave you thanking you to be participating at this webinar. It was really a pleasure to have you here. For the ones missing it, for the ones that had to drop off because we spoke too much time talking, no worries, the webinar will be also on demand in our website, so you can be able to see the webinar afterwards as well. So we will also reply to the further questions that we received, both Vinod and Mr. Sabourdi as well, if any is directly addressed to them. So you will find a reply on that specific one. And so the session is of course recorded and you will be able to see it. You will see all our replies, as I said, afterwards, and this will be published on our LinkedIn page. So don't forget to follow us as well, but of course also to stay tuning, because there is some upcoming news that you will discover soon. Thanks again.